Welcome to the Deep Dive. We sift through the latest research, pull out the key insights, really giving you that shortcut to being well informed. Today, we're tackling an issue that, well, it touches billions of lives, air pollution, and we're going to zoom in on how it behaves over India, one of the most rapidly urbanizing places on Earth. It's a story with some really unexpected turns.
It really is a monumental global issue.
Yeah.
The numbers, frankly, are staggering. You look at the 2021 Global Burden of Disease study. Air pollution was listed as the second biggest health risk, responsible for, 8.1 million deaths that year? Shocking.
8 million, wow.
And the economic hit, it's mind-boggling. $8.1 trillion. That's something like 6.1% of global GDP, just gone.
And India's right at the center of this conversation, isn't it? It's the most populated country, projected to have the biggest jump in urban population globally by 2050. Think about that, only 3% of the world's land, but home to 11% of its urban population. That kind of density, the pressure on resources, it creates huge environmental challenges. Like in 2019, air pollution was linked to 1.67 million deaths in India alone. That's nearly 18% of all deaths in the country that year. Just tragic.
Precisely. And the reality is, you see it in the reports year after year, Indian cities consistently rank among the world's most polluted. And this is where our deep dives really starts. You know how cities create urban heat islands, right?
Yeah.
Hotter than their surroundings.
Yeah.
Well, they can also form urban pollution domes, or the technical term the study uses is urban aerosol islands, UAIs. Basically, areas with distinctly higher or sometimes lower pollutant levels right over the city compared to the areas around it.
Okay, so UAIs, that's the focus. And our mission today is to unpack this really groundbreaking new study. It's the first of its kind to really map out and understand these UAIs across India on such a massive scale.
Yeah, it's quite ambitious.
They use satellite data, specifically aerosol optical depth, or AOD, stretching back almost 2 decades, 2003 to 2020. Which sounds like a really clever way to get around the lack of consistent ground-level data, which has always been a problem in India, right?
Absolutely. Consistent long-term ground monitoring is, well, it's sparse. And AOD, while not a direct ground-level measurement, works as an excellent proxy.
How does that work exactly? What's AOD telling us?
Okay, so think of it like this. AOD measures how much sunlight is blocked by all the tiny particles aerosols suspended in a column of air, right from the ground up to space. So the higher the AOD value, the more particles are in that column, giving us a really good integrated picture of the overall pollution load in the atmosphere above that location.
Got it. So it's a vertical picture of particle density?
Exactly. And this study applied that method across 141 Indian cities. And what they uncovered, well, it reveals some genuinely surprising things about how pollution behaves.
Okay, so the researchers start mapping these pollution domes, these UAIs, across India. And you'd probably expect, just cities being dirtier than the countryside. But what they found was more complicated, a real twist.
That's right. They found 2 distinct types. First, what you might expect, urban aerosol pollution islands, or UAPIs. That's where pollution is higher, right over the city center.
Okay, the classic pollution dome.
Right. But then they found the opposite, urban aerosol clean islands, UACIs, where pollution is actually lower over the city compared to its immediate surroundings.
Lower? How does that work?
Well, that's the puzzle. And the really striking thing, they found a clear geographic pattern, a distinct north-south divide across India in where you find these UAPIs versus UACIs.
A north-south divide. Okay, let's break that down. Where do we see the UAPIs, the pollution islands?
So those are mostly found in southern and southeastern India. On average, these cities showed about a 3.3% higher aerosol load over the urban core compared to the surroundings.
Just 3.3%. Doesn't sound huge.
The average isn't massive, no, but some cities showed much higher peaks, like 10 to 14% more pollution over the city. Think about that, maybe an eighth more particle pollution inside the city limits. That's definitely noticeable, impacts visibility, health.
And the pattern for these UAPIs is what we'd intuitively expect. High pollution in the center, fading out.
Exactly. High AOD right over the city center, and it steadily drops off as you move further away into the non-urban areas. That's the classic dome shape.
Okay, but now let's head north, because this is where it gets weird, right? The UACIs, the clean islands.
This is the really counterintuitive part. In northern India, especially the Indo-Gangetic Plain, they found predominantly UACIs. Here, cities showed on average a decrease in aerosol loading, about -2% lower over the city compared to the areas just outside it.
Minus 2%. So slightly cleaner in the city, that just seems backwards. Why would a dense city be cleaner than its surroundings? What's going on there?
It's a great question, and it points to much more complex dynamics than just cities produce pollution.
Hmm.
The AOD pattern for these UACIs is also really odd. It's often high on the southwest side of the city. Then there's this noticeable dip right over the urban center and the northeast side. It's not a simple dome or anti-dome.
Huh. And does this change with the seasons?
It does. The study noted that too. UAPI, the pollution domes tend to be most obvious after the monsoon season, whereas UACIs, the relatively cleaner city centers, become more frequent and intense during the winter and the pre-monsoon season.
Okay, so UACIs are dominant in the north, especially in the northwest, and they peak pre-monsoon and winter. Now, I know northwestern India gets hit hard by dust, right? Especially pre-monsoon.
Exactly. High dust loading is a major feature of that region's atmosphere, almost year-round, but particularly bad before the monsoon.
So did this study look into that? Is there a connection between all that regional dust and these weird UACI patterns? Because it feels like there has to be.
They absolutely did. And yes, the connection is crucial. It really changes how we need to think about urban air pollution in some regions. They found strong evidence, specifically a significant negative correlation between dust levels in the atmosphere and the intensity of the UAI effect, particularly for those UACI cities.
Negative correlation. So more dust means less of a pollution dome or more of a clean island effect.
Precisely. Let me give you the numbers. Under high dust conditions, 62% of the cities studied showed a UACI pattern, the city being cleaner than surroundings. But under low or no dust conditions, that dropped to only 25% being UACIs.
Wow, big difference.
Yeah. And not only were UACIs more common with high dust, but their intensity, how much cleaner the city was relative to outside, was also much higher when there was a lot of dust around.
Okay, so let's piece this together. What does this actually mean? We usually think of cities as pollution hotspots, generating their own smog, but this suggests that in northern India, maybe the city isn't clean, it's just less dirty than the incredibly dusty air around it. Is that the idea?
You've hit the nail on the head. That's the key insight.
Mm-hmm.
It seems that this long-range transported dust from the Thar Desert, perhaps other sources, contributes massively to the pollution levels in the non-urban surroundings. So when that background level gets incredibly high, it kind of overwhelms or masks the city's own contribution. It effectively punctures the pollution dome that might otherwise form.
Punctures the dome. I like that image.
Yeah. The city isn't suddenly pristine. It's just that the air outside the city has become so loaded with particles, mainly dust, that the city center looks cleaner in comparison.
So why does this happen? Why doesn't all that dust just blanket the city too? What's the mechanism?
It seems to come down to something called the urban wind stilling effect.
Okay.
Think of a city with all its tall buildings. That complex structure creates a lot more friction for wind compared to open countryside. It increases the mechanical roughness.
Right, slows the wind down over the city.
Exactly. It reduces wind speed over the urban area. This essentially creates a sort of invisible barrier, or maybe a pocket of calmer air. It makes it harder for air and the pollutants within it to move smoothly across the city. It's a convergence barrier.
Okay, so this wind stilling effect. How does that explain both types of islands, the UAPIs and UACIs?
Well, think about two scenarios. Scenario one. Most pollutants are being generated inside the city, and the air coming in from outside is relatively clean. In that case, the wind stilling effect acts like a lid, trapping those urban emissions near the source. That builds up pollution over the city, forming a UAPI, your classic pollution dome.
Makes sense, trapping the local stuff.
Right. Now, scenario two. Imagine there's a huge amount of pollution in the background air moving towards the city, like massive amounts of dust blowing in. In this case, that same urban wind stilling effect, that pocket of slower air, actually impedes or slows down the intrusion of those external pollutants into the city center.
Ah, so the city's structure kind of shields the center from the worst of the incoming dust wave.
Kind of, yes. It slows the mixing, so the pollution levels inside the urban core don't rise as quickly or as high as the levels in the surrounding region, which is getting the full blast. That creates the UACI. The city appears relatively cleaner.
That explains the north-south divide then. Southern and eastern cities have cleaner background air, so their own pollution gets trapped, forming UAPIs. But in the north, especially the northwest, the background is so choked with dust and other regional pollution, like from biomass burning, that the wind stilling effect makes the cities less polluted than their surroundings, forming UACIs.
That seems to be the picture emerging from this study.
And what about the seasonal thing? Why are UAPIs clearer post-monsoon?
Well, post-monsoon winds are generally weaker across India. Weaker background winds mean a weaker urban stilling effect. The barrier isn't as strong.
Okay.
So more of that background pollution, even if it's less intense than pre-monsoon, can actually mix into the city. This sort of demasks the city's own pollution contribution, making the UAPI structure of the higher pollution over the city more apparent.
Fascinating. It's like the balance shifts depending on the strength of the regional pollution versus the local emissions and the wind.
Precisely. And it's worth noting, this UACI phenomenon isn't unique to India. They've seen similar things. Cities relatively cleaner than surroundings in places like Shanghai, Atlanta, even some European cities. Often it's linked to things like heavy industry or secondary aerosol formation outside the city limits. Again, boosting that background pollution level.
Okay, this brings up a really important point, though. When we hear Clean Island, UACI, it sounds like good news for the city dwellers, right? Like they have cleaner air. But is a UACI city actually clean? Does it mean the air quality is good?
That is a crucial clarification, and the answer, based on this study, is a clear no. The researchers make this point very strongly. Even the lowest pollution levels, the lowest AOD values measured right in the center of these UACI cities, were still higher than the maximum AOD levels seen over the centers of the UAPI cities in the south.
Wait, say that again. The cleanest spots in the northern UACI cities are still more polluted than the dirtiest spots in the southern UAPI cities.
That's what the data indicates for the period studied. So, clean island is purely a relative term here. Relative to the extremely high pollution surrounding the city, yes, the center might be slightly lower, but in absolute terms, the air quality is still poor, often exceeding safe limits.
Wow. Okay, that's a critical distinction. So a UACI doesn't mean clean air. It just means the surrounding air is even worse.
Essentially, yes. It highlights that the problem of ambient aerosol pollution in many parts of India is just pervasive. It's almost equally dominant whether you're in the city center or in the surrounding rural or non-urban areas.
And the study also mentioned that the overall strength of these UAIs, whether UAPI or UACI, is generally quite weak in India compared to some global examples like Berlin or Beijing.
That's right. The percentage difference between the city center and surroundings, on average, isn't as dramatic as seen elsewhere, which again reinforces this idea that it's not just about isolated urban hotspots, but a much broader regional scale pollution problem across large parts of the country. It affects everyone.
So let's tie this all together. We've got this complex picture. A north-south divide, UAPIs in the south, UACIs in the north, driven by background dust puncturing the domes, and this wind-stilling effect playing a key role. And critically, even the clean islands aren't actually clean.
Right.
What are the big takeaways here, especially for policy? If you're trying to clean up the air in India, what does this tell you?
Well, it points to a potential mismatch in current strategies. The study really emphasizes this. Most air pollution control measures in India right now are very city-centric, focused on reducing emissions within the urban boundaries.
Which makes sense intuitively. Tackle pollution where people live.
It does. But if a huge part of the problem, especially in the north, is this massive influx of regional background pollution like dust, then only focusing on the city's internal emissions might not be enough.
It's like mopping the floor while the roof is leaking heavily.
That's a good analogy. You need to fix the leak too. So this study strongly advocates for a shift. We need to add synergistic regional interventions alongside the local city-focused efforts.
Meaning what? Like tackling dust sources, maybe agricultural burning hundreds of miles away?
Potentially, yes. It means thinking bigger. Coordinated efforts across states, maybe focusing on land management practices to reduce dust generation, addressing biomass burning across the entire Indo-Gangetic Plain, things like that. It requires looking beyond the city limits to achieve real sustainable improvements in urban air quality.
And this isn't just about breathing easier, is it? You mentioned aerosols affect climate too.
Absolutely. These tiny particles have a substantial influence on temperature, how clouds form, precipitation patterns, the whole local microclimate. So understanding where they come from and how they concentrate isn't just a health issue. It's fundamental to creating sustainable and resilient urban environments for the future.
It really changes the perspective. So maybe the key question isn't just how do we clean up this city, but how do we manage the air across the entire region? What if understanding those relatively cleaner dips over cities is actually less important than tackling the massive clouds of dust and smoke they sit within? Especially when you consider the air we all breathe, inside and outside the city.
It's a powerful way to put it.
Something to think about. Thanks for joining us on this deep dive.